Okay, looking at chapter 9.2, functions as words and equations. This is exciting because we're getting into more algebra. The function rule, again, describes a relationship between the inputs and the outputs. I'm reading right out of the book. A function can be written as an equation in two variables. That equation in two variables is something we're going to look at. For instance, y equals 3x. We have two variables, and this is when it gets challenging because everything changes depending on what x is or what y is. The other has to be dependent on it. And so we have the input and the output. And remember, I drew the little function machine, and it comes down here, and there's some little something goes in and something goes out. Well, this function machine, whatever input, see, the x is the input and the y is the output. And so we have whatever goes in, something else comes out on our little machine. And this little machine is multiplying times 3. Now don't get confused. This x is not a times sign. This is just a letter x. But the function is multiplying 3 times. Whatever the x is gets multiplied 3 times because it's 3 times x here. And what comes out is 3 times as big. So if I make my little function chart, and sometimes you can just use a t-chart. The book doesn't give it to you this way, but it's one way I like to do it because it's simple and it takes up less space. That looks like a t. You have the x, which is the input, and you have the y, which is the output. In and out. We have to keep this straight. And if we put something in our function machine, say we put in 0 in our function machine, well, 0 times 3, 3 times 0 is 0. So then the y is equal to 0. If I show you 0 equals 3 times 0. Is that true? Yes, it is. If I rewrite it with a 1 so that I have 3 times 1 instead of 3 times x, then what is the output? Well, 3 times 1 is 3, so 3 is the y. What I'm doing here is I'm rewriting this equation over and over again down here. Say I put in a 2 for the x. That is 3 times 2, or 3 2's. If x is 2, then it's 3 2's, and that is equal to 6, so the y is equal to 6. And if I put in one more, 3, then we get 9, because 3 times 3 is 9. And you can see that we're counting here by 1s, 0, 1, 2, 3, and here we're counting by 3, 0, 3, 6, 9. And that's our input and our output. These do make ordered pairs, 0, 0, 1, 3, 2, 6, and 3, 9. You may or may not need to actually put those into a graph, and it doesn't look like we have to graph those, but we could. And that's one other thing you need to know. So the function rule describes a relationship between inputs and outputs. A function can be written in an equation in two variables. So we have an input, we have an output, and one variable is the input and the other variable is the output. We usually use x for the input and y for the output. And that's just kind of how it goes. We don't have to draw that machine every time. We can just do some of the questions. So it says, example 1, the output is 5 less than the input. And that's a sentence it uses. The output is 5 less than the input. So the output is the y. The input was the x, remember, and the output is the y. So y equals, it says the output is 5 less than the input, and you might need to look at your book. But if it's 5 less, then the output is x, and 5 less than x is x minus 5. So the output is, and is usually means equals, 5 less than the input. So on a function machine like this one, you would be subtracting 5 every time. Whatever x goes in, you subtract 5 and y comes out. And again, we could make a table but we're not required to. All we need to do is come up with an equation that has two variables, an input and an output, and we always need to remember that the x is in and that the y is out. Typically we put the y first and then the equal sign and then the input. And this feels backwards right now, but later on it will make a lot more sense. So you have to change some of these word sentences. Okay, the output is 5 less than the input into algebraic equations. Y is equal to x minus 5. So that's kind of what's on the list, things you have to do. You have to evaluate a function too, which might mean you have to simplify it or solve for it. The example 2 shows y is equal to 2x plus 5. But then they tell you what x is. They say that x is equal to 3. That's the input. So when x is equal to 3, what does y equal? Well, we just have to put 3 in for x and then solve. So I'm going to rewrite this equation. Y is equal to 2 times x. X is 3 plus 5. See, x is 3, goes right into there, right in where the x is. And then we can go ahead and multiply. Y is 6 plus 5. And I'm just showing my work, working down the page, simplifying as I go. And the next one is y is, or equals, 11, because 6 plus 5 is 11. So this is the simplified version of this equation. And it's what I get if I put x equals 3 into the x. If I put that in, I get y equals 11. And on my input-output table, x, y, my input and my output table, if I put 3 in for x, I get 11 out for y. And then my ordered pair would look like this. And I could graph it on a piece of graph paper. The next one is checking your solution. So they say, tell whether xy is equal to 3, 4. So they want to know whether 3 works for x and whether 4 works for y. And they give you an equation. I don't like the way I drew those arrows, so I'm just going to get rid of them. But they give you an equation. They say, well, what about for y equals x minus 2? And then they give you another one because they want you to try it twice. Y equals 5x minus 11. And we're going to put the same numbers in and see what we get. So we're going to put 3 in for x because that's the input. And the output is 4. Okay? And this is the input and the output is y. X is in, y is out. In, out, in, out. And it's a little, I know you might have to look at this a little bit, but just figure it out and I think it'll make it work. So we want to see if it's true. So the output is 4 and x is 3 minus 2. And so 4 is equal to 1. 3 minus 2 is 1. That does not work. Try it over here. The output is 4. Y is equal to 4. 5 times the input is 3 minus 11. And we simplify. 4 equals, well, we can go ahead and multiply 5 times 3, which is 15, minus 11. And we simplify one more time. 4 equals whatever 15 take away 11 is. Well, I guess that happens to be 4. So this one is yes or true. This point on the graph, 3, 4, this input and this output work for this equation, but they do not work for this equation. This is a no. And this is a yes. This equation is yes. Hopefully that makes sense. That's really all you have to do. You're just writing out equations, changing it from words into numbers and letters, and you're solving or simplifying, and then you're checking solutions. That's what today's assignment is all about.